Uh-huh. Good afternoon, ladies and gentlemen. It's January 26, 2022. Okay, this is David De Los Reyes. I'm now discussing a new topic on my channel. The topic for today is the evaluation of integrals involving secant and tangent only. Okay. The last 2 days, I am now through with the powers of sine and cosine, powers of sine only, powers of cosine only. So for today, we will be evaluating problems under secant and tangent only. Okay, let's proceed so we don't waste time. My discussion today is just only a very short one because later on I will add a new, it's not a new topic because it is under the powers of trigonometric function. But you cannot only solve by using identities. There is an additional, so I want to discuss that before I will solve any problem. Okay, let's proceed. Powers involving secant and tangent only. Example number 1, the integral of secant to the 8 of x, tangent of x dx. It involves powers of secant and tangent, Okay? Let's proceed with the solution. This can be written as the integral secant to the 8 is actually can be written as secant of x to the 7, okay, times the quantity secant of x tangent of x. Secant to the 7 plus 1 is actually 8. We just segregate 8, right? We segregate. We change how it was written. Meaning, secant to the 8 tangent of x dx is secant to the 7, secant to the first tangent of x dx. Okay? I think after rewriting the given problem, we could say that it seems it is under the power formula, right? Where the value of u, because if we try to take the differential or derivative of secant, it should be a secant tangent. So I think the solution is under the power formula, where the value of u under the exponent is not is a function, where the value of u is secant of x, the one inside, right? Taking differential du now, the differential of secant is secant tangent times dx, meaning du is secant of x tangent of x dx, and this is exact, right? It is exact. So after the verification, since du is exact, we can now integrate this one to be under the form, the integral of u to the n du, right? And this should be u raised to n plus 1 over n plus 1 plus c. Okay? So the answer will be secant of x, 7 plus 1 is 8 all over 8. We are following this. Secant to the 7 plus 1 is 8 all over 8. That's C. Final answer, 1/8 secant to the 8th power of x plus c. That's the final answer. It seems easy if you know your identities, right? Okay, let's proceed with example number 2. Example number 2 is still under the powers involving secant and tangent only. Example number 2, secant to the fourth of x, tangent to the fifth of x dx equal to, what will be the value? Okay, we will just rewrite the given problem. this will be equal to the integral tangent of x to the fifth power. Okay. Secant to the fourth is secant square times dx. 2 plus 2 is 4. So we just segregate it. Okay? Well, we rearrange. But when you multiply it, it's still the same as the original problem. Okay? This should be equal to the integral of tangent of x to the fifth. Then try to replace secant square by its equivalent in terms of tangent. That is 1 plus tangent square of x equal to secant square of x. Meaning, replace this secant square of x by this value. Right? So, rewriting, this should be the integral tangent of x to the fifth. Okay? Secant square is 1 plus tangent square times secant square of x dx. Then try to expand. Actually, we got two terms. Tangent to the 5 times secant square of x dx is the integral of tangent of x to the 5 secant square of x dx. Tangent to the 5 times tangent square is actually tangent 7 to the 7th power times secant square of x dx. I think for both what comes out is this now falls under still the power formula, because if we try to take the derivative of tangent, it is secant square on the first look, right? So for both the first and second terms after expansion, the value of u is tangent of x. du will be the derivative of tangent is secant square of x dx. Okay, that's differential calculus. So it is exact. So after verification, we can now use the power formula again. So the final answer will be tangent to raise to 5 plus 1, which is 6, all over 6, or just simply 1 over 6, tangent to the 6 of x, plus, okay, this is 7, 7 plus 1 is 8, tangent to the 8 of x, all over 8, so the 8 is underneath, or simply 1/8, tangent to the 8th power of x plus c. Final answer, 1/6 tangent to the 6 plus 1/8 tangent to the 8 of x plus c. That's the final answer. Simple, if you know your identities. Okay, let's proceed with the next topic. We are now through with the powers involving secant and tangent as a combination. So I will give you problem that involves secant only. Okay? It's standalone. It's only a secant, pure secant function. Okay. I almost dropped my camera. Okay, let's proceed with the secant function only. The integral of secant to the 6 of theta differential theta. Secant only. Okay? Secant to the 6 could be a 4 plus 2, right? So actually, we could rewrite secant square of theta quantity square times secant square of theta differential theta. Right? Because secant square of theta to the second power is secant to the fourth plus 2, 4 plus 2 is 6. So if we try to expand this one, it is same as secant to the 6 of theta differential theta. Right? Then try to replace secant square by its equivalent in terms of tangent. 1 plus tangent is secant square. So we could replace this value here by 1 plus tangent square of theta quantity square times secant square of theta, differential theta. We replace secant by this value, then try to expand. The expansion of this, 1 square is 1, middle term is tangent square of theta times 2, 2 tangent square of theta. Third term is the square of tangent square of theta. Tangent square of theta square is tangent to the fourth of theta, closed quantity, times secant square of theta differential theta. Expanding. 1 times secant square of theta differential theta is this one. Okay. 2 tangent square of theta times secant square of theta differential theta. We got a constant 2, so we bring it out, the integral tangent square of theta, secant square of theta, differential theta. The third term will be tangent to the fourth of theta times secant square of theta, differential theta. After the expansion, all the terms are now integrable. Right? The integral of secant square is tangent. For both the second term and the third term, the poles are still under the power formula, where the value of u is tangent of theta, and du is secant square of theta, differential theta. It is exact. Right? So the last two terms under the expansion, under the power formula, the first one is only under tangent. So if we try to integrate the integral of secant square of theta, differential of theta, it will be equal to tangent of theta, right? Power formula, 2 plus 1 is 3, tangent cube of theta, all over 3. But we got it 2 outside, so it will be 2/3 tangent cube of theta. Last one, 4 plus 1 is 5, so this should be tangent to the fifth of theta, all over 5, or simply 1/5 tangent to the fifth of theta plus c. The final answer, tangent of theta plus 2/3 tangent cube of theta plus 1/5 tangent to the fifth of theta plus c. That's the final answer. Okay. It's only short for today because my next discussion will be, it still falls under the secant, but the power is on odd number. If we try to solve that one, you cannot just solve by using identities. There should be another formula to be introduced for us to solve that one. So on my next discussion, I will solve that one, but I will introduce the added solution for us to integrate secant cube of theta differential theta. It falls under secant only, but the power is an odd number. Without introducing another set of solution, you cannot solve that one. That will be my next discussion. Oh, I think that's just more than good enough for today. If you like it, please click like. If you want to share it, please click share. And if you want to subscribe to my channel, please click subscribe. Good afternoon, Los Angeles.